This demonstration looks at the subject of secure data erasure for ZOS systems. Why use secure data erasure? Secure erasure of ZOS data is now required by many of today's government, industry, and corporate privacy and security laws and regulations. Among them, the Sarbanes-Oxley Act, the Health Insurance Portability and Accountability Act, and the European Data Protection Directive, as well as other similar legislation in the USA, Europe, and worldwide. What situations require secure data erasure? Following a disaster recovery, test or reel, the restored data should be fully erased from the recovery disks, especially when using a third-party recovery service. From old DASD subsystems before they are decommissioned, and leave the safe confines of your data center. When internally reassigning a DASD system to a different set of users, or when an audit or security requirements dictate that data should be securely erased from disk. There are several commands and utilities included within the ZOS operating system that can be used to erase your data. TSO ISPF delete command, IDCAMS delete command, ICKDSF minimal init, ICKDSF medial init. Unfortunately, these commands and utilities do not always offer a secure enough level of data erasure to meet today's requirements. And those that are secure often lack the level of performance that is essential when erasing a large amount of data in one go. The TSO ISPF delete command, for example, will remove the entry in the VTOC for the dataset being deleted, but it does not erase the actual data within the dataset, leaving it open to potential unauthorized access. This is generally not a secure enough data erasure. When you run an IDCAMS delete with the erase option, IDCAMS writes over the record 0 of each track and then erases the data on the track. Unfortunately, on some DASD subsystems, the erasure of the actual data does not take place because the DASD controller simply marks the track as logically erased, leaving the real physical data still on the track. This leaves the unerased data open to potential unauthorized access. A minimal init with ICKDSF will delete the entire VTOC on the volume and create a new one, effectively deleting the VTOC entries for all datasets on the volume, but it will not delete the actual datasets themselves. This is illustrated by the following track prints taken before and after an ICKDSF minimal init. In the before report, we can see the VTOC entry for a dataset and also some of the data tracks belonging to the dataset. In the after report, the VTOC has been cleared, but the data tracks remain untouched. For this reason, an ICKDSF minimal init is not generally regarded as a sufficient level of data erasure. A medial init with ICKDSF will delete the entire VTOC on the volume and create a new one, and it also overwrites the record 0 on every track. While this is more secure than the minimal init, it still does not delete the entire contents of the dataset. It is also quite slow in its operation, which is a problem when a large amount of data is to be erased. What's required is a ZOS data erasure utility that can securely erase the actual data and not just the VTOC entry, and that can also do the erasure in the shortest time possible, allowing it to be used for the mass erasure of data. Innovation Data Processing's FDRERASE offers this security and speed. FDRERASE is a cost option to the FDR DASD management family, and it can also be licensed separately. It offers both a secure and fast erasure of ZOS data. FDRERASE version 5.4 level 50 is the first ZOS secure erase utility to complete Common Criteria Evaluation and Validation Scheme, or CCEVS evaluation, and Common Criteria EAL2 Augmented Validation, and has earned the right to display the International Common Criteria Recognition Arrangement, or CCRA certification mark. FDRERASE is also designed to comply with current U.S. government guidelines for erasing computer disks prior to disposal. As well as being secure, FDRERASE is also very fast. On average, it can erase approximately 1.5 terabytes of data per hour per DASD controller. FDRERASE offers two levels of data erasure, Erase and Secure Erase, and also two other utility commands, Verify and Print. The Erase command overwrites each data track with a pattern of either binary zeros or a user-specified pattern. This overwriting process can be repeated up to 8 times, default 1 time. The Erase command will obliterate all data records which previously existed on the track. It meets the DoD NCSC definition of clearing or erasing a disk. The Secure Erase command overwrites each data track with alternating random and complementary data patterns. This overwriting process can be repeated up to 8 times, default 3 times. The Secure Erase command will obliterate all data records which previously existed on the track, and it meets the DoD NCSC definition of sanitizing or purging a disk. Which one should I use? Erase is usually adequate for erasing disks that will be sold, scrapped, or returned to the manufacturer. Secure Erase can be used on your most sensitive data to make it very unlikely that the data could be recovered, even if the hard drives were removed and accessed elsewhere as FBA disks. The performance of Erase and Secure Erase depends on the number of overwriting passes that they execute. A single-pass erase will erase an entire 3390-3 in just under 3 minutes. A 3-pass Secure Erase will take approximately 3 times longer, at just under 8 minutes. To get optimum performance, FDRERASE can erase data from up to 64 volumes concurrently and up to 8190 in any single operation. FDRERASE will automatically spread the load within the same DASD systems and its physical disks to obtain the best performance. A separate FDRERASE job is submitted for each DASD frame. In addition to the Erase and Secure Erase commands, FDRERASE also includes two utility functions. The Verify command verifies that disks have been successfully erased by ensuring that they contain patterns written by FDRERASE. The Print command prints data from selected tracks. This can be used to display the contents of disk tracks both before and after a data erasure to ensure that the data has truly been erased. FDRERASE operations can be initiated either through a standard ZOS batch job or through a supplied set of TSO ISPF panels. This is an example of the primary FDRERASE screen. We have entered 181* in the unit address field to request a display of all the DASD volumes on this system that have an address beginning with 181. This is the resultant display. As you can see, some volumes have already been previously erased by FDRERASE, and we are now requesting the erasure of the volumes at addresses 1810 and 1816. Across the top of the screen, you can see all the valid commands, including suspend, resume, and abort, which allow you to control the initiation, pausing, and canceling of active FDRERASE tasks directly from this screen. FDRERASE offers a fast and secure way of erasing your ZOS data. The initiation of FDRERASE operations is very flexible, either in batch or online. With FDRERASE, you can be sure that all your residual data has been removed from a disk before it leaves your data center.